Now let's go some tests of carboxylic acid. You may have a CO and OH. In fact, this carbonyl group will not have any tests here, but the hydroxy group responds some of the hydroxy functions like reactions like halogenation and so on. But together this CO and OH shows acidic property. Therefore, among the tests of this carboxylic acid, one is a solubility test. They are highly soluble, even the sodium hydroxide soluble, sodium bicarbonate also soluble. Both are soluble tests. Okay, solubility is both positive, means it may be a carboxylic acid. With specifically with the bicarbonate NaHCO3, you will get a liberation of when you add carboxylic acid to the sodium bicarbonate or vice versa. Take acid here, add bicarbonate. Carbon dioxide gas comes out as a effervescence, just like boiling solution giving some hissing noise. CO2 bubbles will be coming and breaking, so that gives a sort of noise, bubble breaking noise, and it will be so many bubbles very small, so therefore it looks like a snake hissing sound. So this is specifically called effervescence. All carbonates, bicarbonates, even inorganic salts also liberate the carbon dioxide when you add HCl or some other acid. Like that, here also acid and bicarbonate liberating the carbon dioxide is one test for the carboxylic acid. Carboxylic acids can be esterified, esterification. Esterification is also a good test. Take any carboxylic acid, add ethanol. Ethanol means a 2-carbon alcohol. Add ethanol in presence of concentrated sulfuric acid and heat it. Boil for some time. All acids get esterified and ester is formed. And esters will have a good smell. Specifically, the fruity smell will be there, pleasant smell or the fruity smell. The smell you may not feel it really with in presence of sulfuric acid. Therefore, add some base like bicarbonate to neutralize this acidity or the concentrated sulfuric acid smell. It is nullified. Then the smell of ester means fruity smell will be coming. That is the test for the carboxylic acid. However, because it is acid, you can also go for the test like litmus paper. The blue litmus paper exposed to this the acid fumes or directly to the acid, it becomes red. Or you can go for the another test like the acids may be converted into the derivatives of acid chloride, like treating with the SO2Cl2, thionyl chloride or PCl5. Thionyl chloride or PCl5, they are converted first into their acid derivatives like acid chloride. Then you add either only ammonia or the aromatic substituted ammonia, anilines. So with ammonia they are giving the amides formation, whereas with aniline, anilides are formed. These are the actually derivative preparation and thereby conforming the carboxylic acid functional group at a higher level. You can do this, but esterification test can be done very simple. Liberation of carbon dioxide is also one of the simple test for the carboxylic acid. Now let's go for the reactions of or testing the functional group of amino group, NH2 group. Basically this group is NH2 group is alkaline or basic in nature. So this basic property can be studied by simple reaction. Take any amine, add the dilute HCl, it is dissolved or soluble. After solubility, if you add NaOH, NF solution, reappearance or regeneration. Regeneration or reappearance of the base. Aniline, for example, if you add HCl, it is get dissolved. single layer is formed. Add NaOH, HCl reacts, NaCl and water is formed, in which it is not soluble. Therefore, again aniline is regenerated. So, regeneration of the aniline, solubility in HCl followed by the base regeneration confirms the amine function. However, amines are giving some characteristic reactions like carbyl amine reaction. But only 1 degree amines give this reaction. Only 1 degree amines are going to give. All aliphatic as well as aromatic 1 degree amines, when you add chloroform and KOH, boil for some time. The amines are converted into the RNC. These NC compounds are called isocyanides or isonitriles. Isonitriles will have a foul smell, very bad smell, offensive smell will be coming. Because of this smell, one can easily identify the formation of isocyanate, thereby confirmed 1 degree amine presence. So, 1 degree amines can be tested with a mixture of chloroform, KOH and boiled. Isocyanate formation gives this foul smell. This becomes a very good test. However, there is another reaction with the NaNO2 or HNO2, in fact HNO2, nitrous acid, this is called nitrous acid. The nitrous acid has got a slightly complicated reaction with different types of the amines. Within the amines also the reaction differs. Let us have a detailed discussion, leaving this nitro group aside. First, let us take the amines can be classified into 2 types, aliphatic, aromatic. In the aliphatic 1 degree, 2 degree, 3 degree. In aromatic also 1 degree, 2 degree, 3 degree. All these 3 amines are going to react with nitrous acid, that is HNO2, in a different way. Therefore, this differentiating test not only amines with other compound, but within the amines also it is possible. Let us see the detailed test of amines with the nitrous acid. So, let us take amines versus nitrous acid HNO2. HNO2 is a unstable acid which is immediately prepared by taking the NaNO2 and HCl. NaNO2, it is a salt of the nitrous acid, is quite a stable potassium nitrate or sodium nitrate. When you add HCl, HNO2 is released. HNO2 will have a structure like this. Okay, HNO2. Nitrous acid plus NaCl is released. This nitrous acid, whenever you want, you take these 2 combination, the nitrous acid comes. Therefore, if you add nitrous acid, means nitrous acid is not available in the lab, it slowly oxidizes. Therefore, readily you cannot prepare and then keep it ready, isn't it? Whenever you want nitrous acid, add salt and acid, you will get the nitrous acid. So, we have 2 types of the reactions. One side we will take aliphatic amines, other side you notice the aromatic amines. In the aliphatic 3 varieties are there, that is aliphatic 1 degree aliphatic amine. Let us take an example of methylamine. Now, aromatic 1 degree, an example of aniline. Okay. Now, the aliphatic 2 degree dimethylamine, let us take methyl plus N and methyl. Still one hydrogen will be there, a lone pair will be there on the 2 degree, right? It is a 2 degree amine. In the 2 degree aromatic, one aromatic, the other side you can notice take a methyl also. Still one hydrogen will be there, a lone pair is there. Okay. Then 3 degree aliphatic means 3 methyls you can take, methyl, nitrogen and methyl and methyl. Aliphatic 3 degree amine. Aromatic 3 degree, that is one is aromatic, the other 2 you can have a rester methyls also you can take, all benzenes also you can take, that is 3 degree aromatic amine, 3 degree aliphatic. Now, the reagent is 1, that is nitrous acid. What happens, you see, when I add HNO2 for the first case, this becomes into initially the methyl diazonium salt is formed, but the diazonium salt is highly outgoing group, therefore it decomposes, gives a methyl carbocation that with presence of water becomes into methyl alcohol. But the N2 comes out as a effervescent, just like a carboxylic acid with bicarbonate NO2, CO2 gas has come. Like that in this case also NO2 gas will come. Whereas in the aromatic case, it becomes into a diazonium salt just like aliphatic, but the aromatic has one advantage. There is a double bond in the benzene and the double bond in the NN gets a resonance stabilized. Therefore, at a low temperature 0 to 5 degrees centigrade, if you conduct the reaction, a red colored diazonium salt is formed, which will retain for the longer time. You can convert by adding water into phenol later, but the color is here no color, colorless, and it is a effervescence of a nitrogen gas. This is no color. Color is not formed, but the effervescence is observed in the aliphatic 1 degree. Aromatic 1 degree red colored is formed, no nitrogen gas is liberated. Now the 2 degree both you add nitrous acid HNO2, both gives the same reaction, and on the N NO will come. The rest of the, that is hydrogen, is replaced by the NO group. This is called N nitroso derivatives. N nitroso derivative. These derivatives are yellow in color. Now we are now interested in the practical approach, not the theoretical reaction. However, theory background is needed, but what color you will get? Yellow color. It is oily liquid is formed. So even this also has got one hydrogen, therefore the moment HNO2 is added, that H replaced. Rest of the benzene and the methyl will be there, but here you will get NO. So same yellow color oily liquid is formed. So it is actually a repetition of the 2 degree aliphatic yellow oily liquid, aromatic 2 degree also yellow oil. That's why 2 degree aliphatic, 2 degree aromatic you cannot differentiate. 3 degree aliphatic, the 3 degree aliphatic and the aromatic again going to differ with the nitrous acid. With HNO2 is added, if I write like this, N double bond OOH, this NO cannot react with the 2 hydrogen so that nitrogen gas goes out or diazonium salt. Not even one hydrogen to get replaced by NO group, isn't it? Therefore, just salt is formed, that's all. A salt you may write like this, 3 methyls with N with the HNO2, or H may be written this side with a plus and NO3 minus, a salt. A solid salt, no color, but a solid white color salt is formed. Whereas in the case of aromatic, the NO plus enters at the para position to the N. So it's an electrophilic substitution. N double bond O comes on the benzene. This is called para nitroso derivative. In the above is N nitroso derivative is yellow, para nitroso derivatives are green in color. Specifically, if you observe the colors of aromatic system, 1 degree aromatic amine red color diazonium salt, 2 degree aromatic amine yellow oily liquids, 3 degree aromatic amines will give a green colored para nitroso electrophilic substitution takes place, that NO enters at para, because it is ortho para directing, ortho positions will have steric hindrance, so the NO goes to the para position to para nitroso derivatives are formed. In the case of 2 degree N nitroso derivatives are formed. So almost all the amines are going to differ with the nitrous acid except 2 degree versus 2 degree. So depending upon the type of the amine given, carefully examine first what amine it is and what is the reaction going to take chemically, or even the physical appearance of the color is very much interested in the amines reactions. Lastly, the functional group NO2, this is there in the advanced only, in the main set is not there, but NO2, how the NO2 test means the nitro group attached to an aliphatic system where the alpha hydrogen, if it is there, this group shows hyperconjugation, therefore it exists in the acid form, and that is why they react with this hydrogen is last shifted, is the enol form or acid form. So, this and that will be in the equilibrium, the tautomeric form, it is not the resonance. In fact, through the hyperconjugation hydrogen shuffles. So, this is acid form, this is nitro form. That is why the hydrogen also react with NaOH. The moment NaOH, if it is added, it becomes a salt also. Sodium salt of the nitro compounds are formed. So, therefore, 1 degree amines, 1 degree nitro compounds like nitromethane or nitropropane. 1 nitropropane is 1 degree. 2 nitropropane is also 2 degree. Both these two, when you add sodium hydroxide, they get dissolved, soluble. Because both are acidic in nature, here hydrogens are there, they show acidic enol formation and then salt formation. Whereas 3 degree, if you take 3 degree nitro compounds like a tertiary carbon nitro, or even aromatic like benzene with nitro also, when you add sodium hydroxide NaOH, they are not soluble, negative reaction, insolubility. So, the primary and secondary, they are soluble in this one, but the tertiary aliphatic as well as aromatic one, they are not soluble in the sodium hydroxide, they shows insolubility. This is the one wonderful differentiation between the tertiary and secondary are 1 degree. But 1 degree, 2 degree, 3 degree specifically in aliphatic system, we have one more common test called Victor-Mayer test. With that test you can differentiate the 1 degree, 2 degree, 3 degree. The test is a Victor-Mayer test. Victor-Mayer test. In this test, we will take a 1 degree nitro compound and a 2 degree nitro compound, right, and a 3 degree nitro compound. All 3 varieties of nitro compounds, 1 degree, 2 degree secondary and tertiary if you take, add the sodium hydroxide, first nitrous acid HNO2. For all the 3 you add the nitrous acid in the step 1. This tertiary, because of there is no hydrogen, they won't react at all. 1 degree, 2 degree both reacts and gives at alpha position you have a hydrogen, therefore that hydrogen gets substituted with N double bond O. So, therefore, the compounds are going to react and give this NO containing compounds. These compounds are called nitrolic acids. Nitrolic acids. This is still acidic because when you add NaOH, it becomes into a salt of that one, a salt of C. Either this or this you can write that let us have a NO, this only I will write so N will have a ONA like this. A salt is formed, the salt will have a O minus double bond all will be in conjugation. So, this salt will have a red color, the nitrolic acid have a blue color, the original compound is said to be colorless, people also saying white color. So, the white color becomes into blue color when nitrous acid added, NaOH if you add it becomes into the red color. Whereas, in the secondary the white color becomes into blue when you add nitrous acid, a blue color is formed. but it is not a true nitrolic acid because there is no hydrogen. Still we have hydrogen here, it is acidic. Here there is no such hydrogen, so it is called pseudo-nitrol. Pseudo-nitrol or nitrolic acid. This is not acidic, that's why when you add NaOH there is no reaction, no red coloration, only blue is the end. So white becomes into blue and stops there, no further progress on adding the NaOH. But tertiary is a white colored compound which on adding nitrous acid there is no reaction. So if all the three compounds are taken, add nitrous acid, no reaction means tertiary. Reaction means maybe 1 degree, 2 degree. After adding NaOH, blue changes to red means 1 degree, no change means it is 2 degree. Therefore, within the nitro compounds also we have some differentiation reaction. So nitro compounds can be tested with some other compound with Victor-Meyer test, or Victor-Meyer test can be extended to differentiate the nitro. In fact, even 1 degree, 2 degree alcohols can be tested with Victor-Meyer. First of all, alcohol is converted into the alkyl iodide by adding the iodine and phosphorus. Then alkyl iodide by adding the AgNO2, it is converted to RnO2. Then apply this Victor-Meyer test. Then the Victor-Meyer test, if it is 1 degree, you will get white becomes into blue, then becomes red. If it is 3 degree alcohol, 3 degree nitro is formed, that won't give any test. So therefore, people also say the alcohols 1 degree, 2 degree, 3 degree, just like Lucas test, alcohols 1 degree, 2 degree, 3 degree can also be tested with the Victor-Meyer test.